Welcome to the 7th and 8th day bonus of the Web Developer in 30 Days from the Basics course. I hope that today's information will be interesting for both beginners and more advanced viewers. What we have done in the course in the last 2 days. We focused quite a bit on the colors. We learned how to define colors in CSS in several different ways, using keywords, the RGB and RGBA functions, as well as using the hexadecimal system. We also learned about the units used for CSS values. We've got acquainted with some of the popular CSS properties. There was also an assignment for participants, during which it was possible to demonstrate the knowledge gained so far. We also learned what default values and inherited values are. But what awaits us in today's bonus? First, we will do a color guessing test based on your deduction. Then I will briefly show you how to define the colors using the HSL and HSLA functions. Usually colors in CSS are defined with the use of a keyword, RGB or RGBA functions, or with the use of the hexadecimal system. And how is color created on our monitor? Each pixel has 3 small dots called phosphors inside, responsible for the 3 primary colors, red, green, and blue. Depending on how intensively these phosphors glow or do not glow, we get a specific pixel color. If the phosphors do not glow at all, we get the black color. If they all glow at full power, we get the white color. 3 questions about the colors ahead of you. You don't need to know them by heart, but you have to guess by deduction. Which value represents the color on the right? As you may know, in the RGB function, we have 3 values for 3 primary colors, red, green, and blue. As in its name, RGB, the values are always in the same order each time. So the first value refers to the red color, the second one to the green color, and the third one to the blue color. On this slide, you can see a color that is something between blue and maybe green, and we can see that there is probably small amount of red color in this example. So you may guess which answer is correct, depending on where we can see the most of the blue color and green color. You may pause the video to think about it, and now I'll give you the answer. As you can see, B is the correct answer, because as we can see in our RGB function, we got small amount of red color in it, and a large, nearly equal amount of blue color and green color. So now let's go to the second question. Now you can see it's kind of opposite. We have a color that is similar to some pink or violet, maybe purple. So we'll probably get a function with a large amount of the red color, with some dose of a blue color, probably having some small amount of the green color. Now pause the video if you want to, and I'll come up with my answer. Of course, the correct answer is A, where we can see in our RGB function, the red color has the highest value, then we have the smallest value for the green color, and some medium dose of the blue color, which makes the effect on the right exactly as you can see. Now let's go to the last question. This might be a difficult one, or a tricky one, as you may call it, because now we have 3 answers. One is referring to a hexadecimal number, second one to a keyword, and the third one to the RGB function with the percentages as the values. I'm not going to give you a hint this time, so pause the video if you have to, and now I will come up with my answer. Of course, all the answers are correct. We can refer to this color by typing this hex number, a keyword of silver, or the RGB functions with the same values for 75%. As I said before, if the phosphors do not glow at all in our pixel, we get the black color. If they glow at full power, we get the white color. And if they glow with the same amount of power for each phosphor, we can get all the shades of gray between the black and the white color. And in this case, if the phosphors glow at 75% of their power, we get the silver color. Another way to define colors is the HSL or HSLA function. It seems more friendly to the graphic designers who are closer to some color theories, and it's sometimes used in some graphic programs. The front-end developers prefer the hexadecimal system or the RGB or RGBA functions. But of course, we will also find those who like HSLA. As you can see on this slide, HSL is also a function, and the notation is similar to RGB. We have also 3 values inside the round brackets, but instead of the primary colors, red, green, and blue, we have 3 other values: hue, saturation, and luminance. And this is what HSL stands for. And like in the RGB functions, these values has to be always in the same order. Just like in the RGB function, we have the RGBA version of it with the alpha channel as the 4th value, which is responsible for the transparency. The first value is hue. The hue is determined by the 360 degrees of the color wheel, with each degree slightly changing the hue. So this value can be set from 0 to 359. The second value is saturation. It determines the intensity of the color and must always be expressed in a percentage, even if it's 0. 0% means no color, so a shade of gray. 100% is the most intense color. The third value is luminance. It means how dark or light our color is. It also has to be expressed in percentage. 0% will always mean black, regardless of hue and saturation. 100% will always mean white, regardless of hue and saturation as well. Here you have an example of a color notation in the HSL and RGB functions, as well as using the hexadecimal system. Remember that each color can be written in any of these 3 ways. This includes the 16 million colors that may be seen on our monitors. Here you can see an example of the HSLA function notation, which is similar to the RGBA notation. We have a 4th value added, which is related to the alpha channel, which is responsible for the transparency. You can Google colors HSL, and this will be the first thing that will pop up in your search results. It's the HSL calculator on W3 School's website. And this tool might come in handy for you if you want to play with the colors with the HSL values and then get them instantly computed to the RGB function, as you can see right here, or the hex number, as you can see right here, as well as we get the HSL function right here. So there you have our 3 values: hue, saturation, luminance. This is what you will get if you change the hue. As I said, from 0 to 360. Here we have the saturation. If we go down with it, we have no color at all, only the shade of gray. And here we have the luminance. If we set it to 0, we'll always get the black color. If we put it to 100%, we will always get the white color, no matter of our saturation, as you can see, and our hue. So this tool might come in handy, as you can see. But for now, thank you for making it to the end of this section, and I invite you to continue learning in the course and to check another bonus at the end of the next section. See you soon.